Hello learners, welcome to this tutorial on Arduino Mega Board programming and simulation. So in this video tutorial, I will be discussing about on how to display a ADC value in a LED array. So for understanding this concept, so I strongly recommend you to look at my earlier tutorial on the basics of ADC and how to interface an LED with your Arduino microcontroller. Then it will be very easy for you to understand this programming. So here in this program, as I said, we are going to use Arduino IDE for writing our embedded C program and for converting this embedded C program into a hexadecimal file. Then our hardware circuit will be developed using a simulator named as Proteus 8 Professional. Then we try to import this hexadecimal file which we have created in the IDE to the microcontroller in the Proteus 8 Professional. So then we try to run the program, thereby we can see the logic of our program, whether it is being correctly executed or not. So what we are going to do in this application, in the sense, we are going to connect a sensor. So the sensor which we are going to use it is a potentiometer. So potentiometer is nothing but a variable resistor. So by changing the resistance value, the voltage given to this Arduino Mega Board can be varied. So we have about 16 ADC channels in your Arduino Mega Board. So it is named as A0 to A15. So I will show them in detail when we try to draw the circuit in a Proteus 8 Professional. So we are going to put the output of your potentiometer to the pin A0 of your Arduino Mega Board. And this Arduino Mega Board has a 10-bit ADC. So 10-bit ADC in the sense, the result after the conversion process will be of 10 bits. So the 10-bit result, we are trying to display it on a LED. So for that, what we are trying to do here is we are going to map this 10-bit result into a 8-bit result and output that 8-bit value to a LED connected to this 4 pins, pin number 2 to pin number 9. So few things we need to understand the program better. So here we talk about a 10-bit ADC. So and it is very important to know about its resolution. So the resolution of your ADC, it depends upon two important factors. One is the reference voltage and also the bit value after the conversion process. So N. So here the formula for calculating the ADC resolution is V reference divided by 2 power n minus 1. Let us assume we are going to use a reference voltage of 5 volt, which is 5000 millivolt, and we have a 10-bit ADC, so N value is 10. So which means we can calculate this value 5000 millivolt divided by 2 power 10 minus 1, which comes about to be 4.88 millivolt. So this is the smallest step in the conversion process, or the first step, or the difference between the step voltages is nothing but your 4.88 millivolt. So this resolution is nothing but this is the smallest voltage which can be represented as a proper binary output. So that is what we call it as a resolution of your ADC. So here minimum I should have 4.88 millivolt so that I can see a physical change in the value of our converted result. So if I want to change the resolution, what we can do, we can either change the reference voltage or I can change the N bit. So N bit, if I want to change, then I have to change the IC, because a particular IC or a microcontroller, it comes with a fixed N bit ADC. So if I want to change the N bit, then I have to change the IC. So it is always better to change the reference voltage. Instead of using a 5 volt reference voltage, I can use a 2.5 volt or 1.25 volt. So depending upon that, we can have a higher resolution. So after the conversion process, what happens? We will get a value between 0 to 1023. Since it is a 10-bit value, 10-bit result. So 2 power 10 is nothing but 1024. So we will get a binary value between 0 to 1023. So this 10-bit value, in order to showcase in our LED, we are going to map this 10-bit value to a 8-bit value. So we are going to map the 10-bit value to a 8-bit value. For that, we will be using our library called as map function, and using that map function we try to convert this value 0 to 1023 value to 0 to 255. So thereby 2 power 8 is 256. So we can have a display between 0 to 255, and this value will be outputted to your LED. So here in the LED, the pin number 9 will be your MSB value, and the logic in pin number 2 will be your LSB value. And remember, here we are not trying to display the 10-bit result, we are trying to map the 10-bit result to a 8-bit value, and that 8-bit value will be displayed in the LED array. So if I want to measure the voltage, what is the actual voltage measured in this A0 pin? So for that, we can make use of this formula. This measured voltage equal to ADC value. So ADC value is nothing but the value which we obtain after the conversion process. So this is a 10-bit value, and it is multiplied by the ADC resolution. So we already know how to compute the resolution of your ADC. We already know how to compute the resolution of your ADC. So that value can be plugged in. So for example, if my 10-bit value is a 512, then this 512 is multiplied by 4.88 millivolt. So this 4.88 millivolt is obtained by using a reference voltage of 5 volt and 10-bit ADC. So when I multiply it, we will get 2499 millivolt, which is equivalent to 2.5 volt. So when I give a 2.5 volt to the A0 pin, then we will get a value of 512 after the conversion process. So by multiplying this 512 with 4.88 millivolt, we can get what is the voltage at the ADC channel pin. So that is what we do in this program. So now let us dive onto the programming as well as the hardware circuit implementation part. First, let us build our Proteus 8 based hardware circuit. So let us create a new project. So here I have to select a location where I am going to save my project. So I will name it as ADC LED, and I am going to use this folder for putting our project files. Then I am going to give a name for the project with an extension of .pdsprj. So again I will give the same name, ADC underscore LED. It need not be the same name, you can give any name for the project. Then press next. Then I am going to use a default schematic to build our circuit. Select the default schematic, press next. We are not going to create any PCB layout, so I will leave it as it is. Press next. Then we are not going to use any firmware, so I will leave it as it is. So finally you can see 1D schematic we have selected. Press finish. So it will open this window where we can build our circuit. So the first thing which we need to do is we need to pick the components which we require for our circuit. So for that I go to this pick device. In keyword I type Arduino. So we select Arduino Mega Board. It gets added to the list. Then we require a bar graph LED, which is nothing but an array of LEDs. So bar graph LED, let me select a red color here. It gets added. Then we also require a potentiometer. I'll type it as pot. So potentiometer, again we have different versions. Let me take this pot HG, which is an interactive type of potentiometer. Thereby I can increase or decrease the resistance values. So let me add this to our circuit. So these are the things which we require in our project. So after selecting all the components, we try to press OK. Now using these components, let me build a circuit, put the Arduino board onto your schematic, and we need to connect the potentiometer to pin number A0. So here let me zoom it and show you. So here you can see this pin numbers A0 to A15. This is your 16 channel. You can see analog input in the sense the 16 channels are connected to the ADC of your Atmega 2560 microcontroller. So we are going to use this pin number A0 to connect our potentiometer. So I place a potentiometer here. Center terminal I connect it to A0. So one end of the potentiometer I connect a power supply. So in order to connect a power supply, go to terminals mode, select power, place it onto your schematic, then connect the power. Then again for connecting the ground, go to terminals mode, ground, place it onto your schematic. So this completes our analog input part. So we have connected our sensor to A0 of your microcontroller. So next what we are going to do is we are going to connect our LED, bar graph LED to the microcontroller. So for that again I go to components mode, I select bar graph LED. So for better visualization, let me rotate this bar graph LED anti-clockwise and place it here. So I am going to connect from pin number 2. So here I am going to take 8 LEDs here from pin number 1 to 8. I am going to use it here. So first pin number 8, I will connect it to pin number 2. 7 is connected to 3. 6 is connected to 4. 5 is connected to 5. 4 is connected to 6. 3 is connected to 7. And 2 I am going to connect it to 8. And 1 I am going to connect it to 9. So this is how we have connected the anodes of your LED to your microcontroller pins from pin number 2 to pin number 9. And the cathodes we need to ground it. For grounding it, let me go to the terminals mode, select ground, put it onto your schematic. Then I am going to connect this ground to all the cathodes here. 20 is connected, 18 is connected, 19 is connected, 17 is connected, 16 is connected, 15 gets connected, 14 gets connected, 13 gets connected. So we have not used 2 more LEDs, 9 and 10 anode LEDs and 11 and 12 cathode LEDs we have not used in our circuit. So this completes our circuit part. So we have connected 8 LEDs to pin number 2 to 9 and a potentiometer is connected to a A0 pin of your Arduino Mega Board. So once we have done with the circuit, save the project. So now let us go and write the program for this application. So the application here is we need to read this potentiometer value, convert this analog value to a digital value. Then the digital value will be a 10-bit result and the 10-bit result will be mapped to a 8-bit value. Then the 8-bit value will be displayed in your LED array. So that is what we are going to do in this program. So let us go to the Arduino board. So here I am going to use a logic for sending a 8-bit data to your GPIO pins. For that, I recommend my earlier tutorial on how to send the GPIO data or use the GPIO pins as a port lines. So for that, we need to include this library function IO port underscore 8bit.h. So that can be downloaded and it can be included in your library part. So once we have done this, we can include it in our program. So the main aim of this IO port underscore 8-bit header file is we can send the data as a 8-bit format through the pins of your Arduino Mega Board. So first we need to define those pins. So in order to define those pins, we are going to make use of this library. So we use IO port 8-bit and we are going to give a name, something like a user defined name, port underscore pins, and we need to define which pins will be carrying the 8-bit data. So I am going to use 2 to pin number 9. So 8-bit data, and important thing here to notice, the 2 will have the LSB data and 9 will have the MSB data. So the 8-bit value will appear in this pins. Then we have two functions, void setup and void loop. So in void setup, it is mainly used for configuration part. So here we need to configure this pins 2 to 9 as an output pin since we have connected LED to it. So for that, what we do, we use this port pins, which is a user defined name for the pins, and set the IO direction as output. This makes all the pins, pin number 2 to 9 as an output pin. Then we have one more pin which is connected to a potentiometer. That should be declared as an input pin. So for that, we use pin mode function. Pin is A0 and it is initialized as an input pin. So this completes our configuration part. Now we can go and write the logic in the loop function. In the loop function, we need to read the analog value. For reading the analog value, we use a function called as analog read. Analog read, we have 16 channels are there, A0 to A15. Our potentiometer is connected with A0. So we are going to read the value from A0. And this value will be a 10-bit value. After the conversion process, it will be a 10-bit value. So we try to store that value in an integer variable named ADC underscore value. So remember, this ADC underscore value is a 10-bit value. So in order to show the value in the LED, what I am going to do is I am going to map this 10-bit value to a 8-bit value. 10-bit value in the sense it can have any of the 2 power 10 combinations. So 2 power 10 combination in the sense 1024. So 0 to 1023, any value can be there. So this value needs to be mapped with 2 power 8. So 2 power 8 is 256. So we are going to map it with 0 to 255. So in order to do that, I am going to use a function called as map. What is the value? This whatever red value we are going to take. So this ADC value will be a value between 0 to 1023. We need to map this 0 to 1023 to 0 to 255. So that gives the mapped ADC value, and this also is declared as an integer variable. So now we have an 8-bit data here in mapped ADC value. So we can send this value through the port pins which we have initialized earlier. So I use a function port pins dot send 8-bit data, put this mapped ADC value so that it goes and makes the LED to be either in on state or off state depending upon the value, and this value gets retained for 300 milliseconds. And once again, since this is a loop function, the code runs infinite number of times. So again, the sensor data is read and it gets converted into a 8-bit value, then send that value to LED. So this process continues continuously, infinite number of times. So as I change the input voltage, you can see the binary bit pattern in the LED also gets changed. So now let us save this project. Let me put it as ADC underscore LED. It has to be saved with the extension of .c. So save. Once we have saved this, we can do a compilation which checks for the syntax error, and we can convert this hexadecimal embedded language program into a hexadecimal file. So for that I can go to Sketch, export compiled binary, which will do both the operation. First it will do compilation, then convert your embedded C program to a hexadecimal file. So we can go and check in that location. So in Arduino, I have ADC_LED. Here you can see this is the hexadecimal file which we have created. So we can open it in a notepad and look at it. This is the hexadecimal file for our corresponding embedded C program. Now this file we need to import it into the program memory of your Arduino Mega Board. So in order to do that, we go to Proteus, right click on your IC, edit properties, select the program file. So here I am going to select the program file of your ADC_LED. So select the hexadecimal file. So we try to import the hexadecimal file into the program memory of your Arduino Mega Board. Once this is done, press OK. So now we have imported it. Now we have to check whether it is working properly or not. So in order to do that, we press the simulation button. Right now you can see it is showing a value of, so this pin number 1 in the LED is your MSB and 8 is your LSB. So it gives 0 and 7 ones are there. So 0, 7 ones. So we have a voltage of about 50% voltage. 50% in the sense it will be almost 2.5 volt. So when I increase this value, you can see there is a change in the binary bit pattern displayed in your LED. As I start increasing it, you can see the values gets changed. Now when I go down, you can see again the value gets changed. Let me go below 50%. You can see it varies. So like that we can display our ADC value in the LED array. So one more thing which we can do is let me stop this program. We can add a voltage probe so that we can visualize what is the value of your voltage to the A0 pin. So in order to do that, I can go on the left hand side. Here I have something called as a probe mode. In probe mode, you can select for voltage measurement. So I can place this voltage measurement at this point. So we need to measure the voltage at this point. Let me save the project. Now let me run once again. Now you can see right now it is 2 volt is being displayed here. So as I start increasing, you can see 2.05, 14, you can see here the voltage gets changed and we get a corresponding binary bit pattern here, 8-bit binary bit pattern. So you can see as I go 50%, it is almost 4 point. As you can see here, it keeps on increasing. The voltage keeps on increasing and you can see the corresponding binary bit pattern. So when it reaches a 50%, which is almost equivalent to 2.5. So for that we have a binary bit pattern of 0, 7 ones. So like this we can display our ADC value in a LED array and we can see. So with this we conclude this tutorial. So thanks for watching and please subscribe for more technical learning. Thank you.